The good news is you are exquisitely well designed. What fitness is about lodging your genes as far into the future as you can get them. The bad news is that you are exquisitely well designed for an environment that we don't live in. Our environment is not only so radically different from the one that we evolved in, but also so rapidly changing that it is not possible, even in principle, for us to keep up with it. This dark age is about us having gotten off track and forgetting how science is supposed to work. Every great idea starts with a minority of one person who gets it first and is against the consensus. Scientifically, we hear that something is a paradox and we think, oh God, that sounds frustrating. You can't reconcile those, huh? It's not how you should feel. You should feel excited. Hello, hello. It is a great honor to be here. We are really impressed at what we have seen at Ralston. Before I get going, I did want to pick up on a theme from Heather's talk. I trained as a mammologist. I studied bats, and there are lab practicals involved in becoming a mammologist, and the head of that division of the Natural History Museum had a couple of trick questions that he liked to present in the lab practicals. So he'd put out skulls, and you have time to look at them and figure out what it was you were looking at and what characteristics it was that told you that this was the animal in question. And one of the trick questions was he would put out a bear skull and a seal skull, and it is virtually impossible to tell them apart. If you know what you're looking for, you look at the teeth. A seal skull has teeth built for eating fish, and they look very different than the bear skull. But other than that, they are virtually identical once you take the skin off. So this really is a kind of deep understanding. The other trick question, one that almost nobody ever got right, was he would put out something like 20 dog skulls, domestic dogs. And what we have done to dogs is radically alter them so it looks like you're looking at 20 different species, but you're not. You're looking at variation of a kind that doesn't really exist in any other creature. So anyway, there is something very important about figuring out how not to be misled by the superficial characteristics and how to see the deep, high-quality evidence. All right, my talk is biological nature to what end? And I want to make sure that you understand I have a couple of objectives in this talk. There's going to be a number of points that I think are significant that I hope you will glean. But in the end, there are really two things above all else that I want you to get from this and also the talks that we will be giving tomorrow. The first is what I think is a profound question that I almost never hear asked. And the question is, why does the inorganic universe give rise to the biotic universe? We hear the question asked all the time, how? How is it possible that biology happened in an inorganic universe? But we don't ask, what is the driving force that causes that transition? And so I'm hoping that you will have at least an inkling of that by the time I'm done. The other thing I want you to get is, I'm trying to put it gently, but there's an important message for people who are human-oriented. If your bent is the humanities, it's natural to think that the study of organic evolution is perhaps interesting, but it's not fundamental to what you're doing, and I quite disagree with that. I'm not telling you that you need to go check with the evolutionary biologists about what you're studying. They may not understand it either. But what I am telling you is that human beings are a consequence of this evolutionary force, and that it impacts our history as people in ways that are so utterly profound that you can't afford not to be interested at this level. If you want to be good at the humanities, this is a way to turbocharge that, is to understand the underlying biotic dynamics, what they predispose us towards and against. It's a very potent toolkit. It is also the very best toolkit for a human being that wants to solve the problems of how to live a fulfilling life. We are set about a number of very difficult puzzles as modern people. How are we to live? What should we eat? What should we make of the advice given to us by our doctors? How should we confront the modern world of mating and dating? These things are all built on a substrate that is evolutionary, and so you have everything to gain by tapping in to what we do know and figuring out what we don't yet know. All right. The good news is you are exquisitely well designed. The bad news is that you are exquisitely well designed for an environment that we don't live in, right? You are a bit like this bee in this photograph if he were trapped in a house. Actually, I should say, if she were trapped in a house. If she were trapped in a house, she'd be banging into the windows, trying to get out. Looks like a clear path, and it isn't. She would have to figure out what it meant. Why do you have to fly down a hallway to go through a door? That's not a natural thing to be faced with. It's a very confusing and damaging phenomenon for a creature like that to be stuck in an environment as weird as a house. And we are like this constantly. This is what Heather and I mean by the term hyper-novelty. Our environment is not only so radically different from the one that we evolved in, but also so rapidly changing that it is not possible, even in principle, for us to keep up with it. We are constantly a fish out of water. We are also, unfortunately, and I think unnecessarily, living in what I would call a cryptic dark age. Now that's going to sound paradoxical. It seems like we are living in an age of enlightenment. The pace of scientific work is probably at an all-time high. I feel almost certain of it. But the problem is that that pace of scientific work, the number of papers that are published, is not mirrored by the furious pace of profound new discoveries. In fact, if you know how to read the literature, you'll find a dearth of discoveries. In my field, evolutionary biology, I would say there hasn't been a significant discovery since I was 7 years old. 1976 was the last time we made a big breakthrough in evolutionary biology, and that's not because there isn't a whole heck of a lot to discover, it's because we've forgotten how to do it. This dark age is about us having gotten off track and forgetting how science is supposed to work. We've also lost the wisdom of the ancients. Here I have a picture of the statue of Mammology in Cordoba, Spain. This is one of the ancients. He was a philosopher who thought very deeply about medical questions, and his wisdom is lost to modern medicine. We don't even think about it. It's too antiquated to bother ourselves, yet we're poisoning ourselves with all kinds of pharmaceuticals that he would have seen right through. All right, so we have to remind ourselves what science is and how it works. And that's a demeaning thing to say, but I believe it literally. We are not doing science. We're doing a lot of stuff that has elements of science, but it does not have the core elements, the necessary ingredients to make it work. So what is science? Science is the building of useful models, and it only works if you adhere to the underlying philosophy. Science is a method. It doesn't require you to have a degree. It doesn't require you to have a grant. It doesn't require you to be anything other than curious and ready to stick to the method. If you do that, it works. If you don't stick to the method, no amount of high-tech wizardry gets you out of the puzzle. You will talk yourself in circles. You won't get the right message. So we have universities filled with scientists, and we are wasting all of this resource on them because they think they've evolved past the method. Data collection alone is not science. It doesn't work. At best, data collection is the first step of the scientific method, observation. But if that's all you do, just repeated observation, you're not being scientific, and we shouldn't expect it to spit out great insights. Okay, last point here is the arbiter of what is true is one thing and one thing only. It is predictive power over the long term, okay? It is not about your credentials. It's not about whether or not the idea has been peer-reviewed. It's not, above all else, about consensus. In fact, I would point out every great idea starts with a minority of one. one person who gets it first and is against the consensus. If you rule out that person who believes something alone because he's violating the consensus, you have ended science right there. It will not continue. So we have to get past this idea that we can spot science by kind of looking at what looks scientific to us. That will not work. Okay, I want to take some of the basic ideas of how science functions and reformulate them in a way that I think is new. There's a continuum between two properties. One of those properties is paradox. And when we talk about a paradox, what we're talking about is something that cannot be reconciled. You believe two things are true, but you can't make them live together in the same model. That's a paradox. And paradoxes have a bad rap. Scientifically, we hear that something is a paradox and we think, oh God, that sounds frustrating. You can't reconcile those, huh? It's not how you should feel. You should feel excited. You hear that there's a paradox, that means, hey, there's important work to be done there. We could figure something out. If we can figure out how those two things that don't fit together can fit together, we've learned something important. So Heather and I say that paradox is like an X on the treasure map. It's telling you dig here until you get it. And this used to be better understood. I would point out Schrodinger's cat. We all know the example of Schrodinger's cat. It's a description of quantum mechanics in which Schrodinger has arranged a thought experiment. There's a cat in a box that will be killed if a radioactive isotope decays. There's no way to predict if it decays. And if the radioactive isotope decays, a hammer will fall and break open some poison and kill the cat. Is the cat alive or dead? Well, quantum mechanics tells us the cat is both alive and dead until you open the box. Now, Schrodinger did not posit this thought experiment as a way of explaining quantum mechanics. He issued it as a challenge to his colleagues. He was telling them, what you believe is too stupid to be right. That can't possibly be true. The cat is not both alive and dead in the box, so get to work. It's a paradox. Now, that was in the 30s. We still don't know the answer. So again, we have stagnated. We don't know why that paradox is there. But that paradox should be telling us something. When we hear there's a paradox, it means there's some profit to be made. Now I want to go to the other end of this continuum, and I want to talk about tautology, which Heather touched on briefly. Tautology, if you think paradox has a bad rap, tautology has a really bad rap, philosophically speaking. And there's a reason for that. A tautology is something that can't help but be true, right? So if I say all tall people are above average in height, that's a waste of time, right? You haven't learned anything. So we get the sense that tautology is always a waste of time, but it isn't. I want to call our attention to what I would call productive tautologies. Productive tautologies are things that cannot help but be true, but in phrasing them, they allow us to look at other things that we don't yet understand and gain clarity about them. So stop fearing tautology. Tautology, just like paradox, is a good thing. And I would just say, if you think about these two things as like guardrails, paradox on the one hand, paradoxes are things that cannot possibly be true. Tautology, these are things that cannot help but be true. Everything that might be true is in between those two things, right? That's where we do the work. That's where we learn. So these are the guardrails, and we got to get to work in that zone between paradox and tautology. All right. Also, Heather indicated that all true narratives must reconcile. This is really the key principle that undergirds science, right? When you have two things that don't reconcile, whether it's between two cultures or two disciplines, we don't allow ourselves the cheat of saying, well, maybe they just don't fit. We say we are required to make them fit over time. And so that is an important principle. Okay, Heather also had a periodic table I was encouraged to see. I'm going to use the periodic table for a little bit of a different purpose. I want to illustrate something about the abiotic universe before we get around to talking about the biotic universe and why it exists. There are 4 properties that explain how common any pattern in the universe is. So on the periodic table of elements, we have a bunch of different atoms. We can say that the commonality of any of those atoms is a product of these four properties. The four properties are the tendency to come into being, the durability once you've come into being, the similarity so that we can recognize that there's a category, and the tendency to accumulate stuff that is limited. So Heather alluded to protons. How good gold is at accumulating protons has a lot to do with how much of the universe's matter is tied up in gold. All right? How often gold comes into existence turns out to be limited by the fact that the only thing that creates gold are the kinds of conditions in a supernova. That's where all the gold came from. Gold is very durable once it's formed. It doesn't radioactively decay. So you get all of these properties together tell you how much gold there is. That same set of principles works for anything else too. If you want to know how common spiral galaxies are, it's the same question. How often do they come into existence? How long do they last? How similar are they so we can recognize them as spiral galaxies? And how good are they at accumulating stars and planets and dust? Right? Those properties work for any pattern. That's how we know how common things are. And the last of those things, the tendency to accumulate limited stuff in the universe, sounds a little competitive, doesn't it? Now, it's not true competition. Spiral galaxies don't care if they accumulate stars. They just do it because stars have mass and that gravity causes things to attract each other. But this is a precursor, logically speaking, to what will go on to be competition. Okay, so the universe has a precursor built into it. And that precursor looks an awful lot like competition. I would also say, sort of key punchline to this piece is that set of properties that tells you how common a pattern is going to be in the universe is actually a description of selection. Now notice, usually when we say selection, we mean natural selection, and that requires biology. But that's, in a way, a logical error. Selection exists in the universe before there's any biology. Selection is the force that decides what patterns are going to be common and what patterns are going to be rare. So selection is not the central element of biology. So that leaves us with a puzzle. How does matter go from that? That's a picture from the Hubble Deep Field, a bunch of cold galaxies, to that. Okay? Now, this is a sea otter. If you look really carefully at that picture, you can see that sea otter doing something very special, something unique to the biotic world, but ubiquitous. All the creatures in the biotic world do it. What that animal is doing is it is striving. It is striving to do something it doesn't understand. It probably thinks it's striving just to break into that clam, which I will tell you it did. But it is actually striving to do something else. It is built to strive towards an objective that you do not need to know in order to accomplish it. All right, here's another example. Here we have water doing what water does. Water flows downhill. Here we have a salmon. A salmon is mostly water. This salmon is flowing uphill. Why? It's striving. It's striving for an objective it does not understand, an objective it does not need to understand. So what is the difference? If it's not selection that is causing the striving, it has to be something. And it is the combination of selection that exists in the prebiotic universe plus heredity. Heredity, that is the passing of information from one generation to the next. As soon as you put those two elements together, you get adaptation. And adaptation is the thing that makes the biotic universe so special. Because adaptation allows the accumulation of traits that augment that fourth characteristic in that set of properties that makes things common, the tendency to accumulate limited stuff. So once you get heredity added onto selection, what you get is full-fledged competition. The creatures that are competing don't know what they're competing about. but they're competing to accumulate limited stuff because that's the game. All right. Now, adaptation is obviously closely associated in the Darwinian scheme with the concept of fitness, right? We talk about survival of the fittest. Darwin didn't use that phrase, but it doesn't matter. It's a reasonably good encapsulation. You will also notice, as its critics often point out, it's pretty close to a tautology, right? Survival of the fittest. Well, what's fittest? It's the stuff that survives, so sounds tautological to me. On the other hand, it's a useful tautology. It's one of these things that once you realize that all those creatures are striving to be fit in some particular way, even if you can't spell out exactly what it is, you can learn an awful lot about what the nature of that competition is by the various styles of competing that you see out there. But something kind of tragic happens in evolutionary biology surrounding the concept of fitness, and it happens for a completely understandable human reason. So just as people in the humanities sometimes have science envy, right? They look at scientists and they think, it'd be kind of cool to have a toolkit that allowed you to just get to work and know exactly, what to measure and that sort of thing. Well, just like that, biologists have physics and chemistry envy, right? If you're a biologist, you're dealing with a complex system, and that means that anything you want to do, you're just dogged by noise, right? There are 1,000 factors that impinge on your experiment. You can't isolate something so you can just run a test and know the answer. You're stuck using statistics and things like that in order to get rid of the noise so you can see the signal. So biologists, having physics and chemistry envy, tried to figure out how they could measure fitness, right? It's a laudable goal. Let's measure fitness. We'll go out in the woods and we'll see, how evolution works. And the problem is that what they settled on was actually not too bad. They settled on reproductive success. And they went out and they measured reproductive success, and they got really good results, which is where the tragedy happens. Because when you get really good results, you start to think that was the right move, right? Maybe fitness is reproductive success. Maybe the problem is solved. And reproductive success works 95% of the time. In fact, here's an example on the screen. I can't see the screen. I assume you're looking at an ant carrying a leaf, carrying another ant. Okay, well, here's the thing. Darwin was a marvelous guy, wonderful scientist. He spent a lot of time worrying about stuff that didn't quite work with his model, and he spent a ton of time worrying about ants, because ants seem to violate the whole notion. They're way too cooperative. Why are they doing all of the sacrificing that they do and not reproducing, frankly? Seems weird, right? So anyway, he worried about that, and he did not know the answer, but it turns out we now do know the answer. Genetic work has revealed that ants, bees, and wasps, which all have this behavior, the behavior is called eusociality. Eusociality means that some members of the colony forego reproduction in favor of other members in the colony. In the case of hymenopterans, all of the workers of the colony, all female, do not reproduce. Instead, they foster the reproduction of their mother, who produces sisters for them. Now, the reason for that is that there is a weird genetic system inside ants, bees, and wasps called haplodiploidy. And for reasons I won't explain here, haplodiploidy means that the offspring of their mother, their sisters, are more closely related to them than their own offspring would be. So, if you follow this logic, they are effectively doing a better job at reproducing by not reproducing and helping their mother do it than they would be able to on their own. So they've actually been physically modified so they can't even reproduce. So that success tells you, you know what, this reproductive success measure is really good. That's fitness. Fitness is reproductive success. And if you think about it, you've probably heard claims that reflect this as a layperson. You've heard that the whole point of evolution is more offspring, and that explains everything. Well, no, it explains 95% of everything. But what it also does is it confuses us any time it's not true. And it's not true in a lot of really important places. So that weird genetic system explains ants, bees, and wasps so beautifully that, we very proudly teach it when we teach evolutionary biology, and we rarely teach that termites do the exact same thing. They're eusocial. The workers don't reproduce. They facilitate the reproduction of the queen, and they don't have the weird genetic system. All right? So we're right back where Darwin was worried. Now, my point is, what we should have done is just remembered that we cheated. We should have said, reproductive success isn't exactly the same as fitness. It was a proxy for it. And if we had remembered that, then we would know to be looking for some other answer when we got around to things that were paradoxical. But we don't, because enough academic generations have passed that the people who made that decision to begin with are all long gone, and the graduate students who picked up the idea that reproductive success and fitness were essentially the same thing became the professors. And anyway, it's just become the sort of bedrock that the field is built on. Termites have this system. They're not haplodiploid. Naked mole rats have this system. They don't, workers don't reproduce. They foster the reproduction of their queen. They don't have the weird genetic system. So anytime a creature's fitness isn't closely tied to reproduction in this particular way, we get confused, and that's part of why the field has gotten stuck. We forgot where we decided that a rule of thumb, we thought that a rule of thumb was a rule. Oh, and by the way, there's an argument to be made that humans are also eusocial. A very special case, but I guess I'll get back to the Catholics later. I hope I don't go to hell for bringing it up. But there is some interesting stories to be told about modifications to the usual reproductive order, even in humans. Okay, so if fitness isn't inherently about reproductive success, what is it about? Well, I'm just going to take an obvious tautology that is never said, and I'm going to say it, and you're going to see why it has to be true. What fitness is about lodging your genes as far into the future as you can get them. Okay? Now, how do we know that that has to be what it's about? Well, we are living in the future. We're living in the future of all of the creatures that came before us. And if you think about what those creatures were doing, any creature in that past that was not doing everything in its power to get its genes into the future was beaten to the future by creatures that were. So what I think you've just learned is that there is a natural bias in the universe towards doing whatever it takes to get your genes into the future, and that's why we are here and the creatures that aren't here aren't, right? It's a tautology. So, lodging one's genes in the future is the game. But that has some really powerful implications. And they're counterintuitive. So, am I right? You see a hummingbird on the screen? Okay. So that hummingbird is a theropod dinosaur. It's not derived from a theropod dinosaur. It is one, okay? It is one because it is a member of the lineage of theropod dinosaurs, and I will get back to that term in a second. It's a very important one. But here's the point. If you were a theropod dinosaur 65 million years ago, and the question was, how are you going to get to the future? Well, the answer is you can't go looking like that, right? You're going to have to go some other way. And so the point is, we all, for some reason, get taught that dinosaurs went extinct. Didn't happen. The truth is way cooler than that. You're living in the age of mammals, right? Age of mammals, we all agree. Do you know that there are more than 2 species of living dinosaurs for every mammal species on Earth today? There are. You probably saw some on your way here. Birds. They're actual dinosaurs. And they are dinosaurs that changed form in order to get into the future. Now, a whole lot of dinosaurs did go extinct, right? Most of the dinosaurs went extinct at the KT boundary for whatever reason. Probably Chicxulub, the comet that hit the Yucatan. But nonetheless, the point is it valid from an evolutionary perspective to change forms radically in order to get into the future? Of course, it's as valid as anything else. Right? It's just another way to do it. So that's the thing that you should be looking for, is if you know that the game is about getting your genes into the future, the question is, what are the various ways that that might be done? And the answer is biology is giving you a pretty good survey of the various possibilities, right? All of those strategies, whether, it's an elephant seal or, a fungus with a symbiotic relationship to trees, all of those are just ways, they're gambles on ways of getting into the future. All right, a last point here. There is something about genes that's intuitive. If I say that genes will do anything to get into the future, you kind of get it, and you probably have some sense that that might not be an entirely good thing, that some of the things the genes might be willing to do aren't so fantastic. But you probably have a misimpression that that's because the genes want to show up. They want to be there in the future and create feathers and all of that. And this is not right. Genes have unbridled ambition. They will do literally anything to get into the future. And we will get to some of the horrifying things they do and what we should think about them later. But they want to get to the future. But one of the strategies for getting to the future is being quiet. And the genes are perfectly willing to do that. Anytime a gene is more likely to get into the future by not making any impact in the world, it's perfectly willing to do that. It's no worse than making an impact in the world, changing the phenotype of an organism. And I will tell you this, it also will sound quite counterintuitive, I'm sure, but your existence is actually wholly dependent on the willingness of genes not to do anything. You are a 30 trillion cell organism, and you've got a genome of something like 20,000 active genes. There might be 5 edits on average per gene, so you've got something like 100,000 genes to work with to encode that 30 trillion cell organism. You're divided into something like 200 cell types, but in all of your cell types, most of the genes are silent, right? You're not producing digestive enzymes in your eye because it would blind you. So the digestive enzyme genes just silence themselves. There's no argument about it. They're in perfect agreement about making you a successful organism by being quiet. And they can be quiet for generations rather than just in this part of the body or that part of the body. They're perfectly willing to be silent. So what I want you to remember is genes have unbridled ambition and zero vanity. They do not care if they show up in the phenotype or not. Okay, so one of the consequences of thinking about evolution in this way is that it begins to let you, if you accept the tautologies, then you can begin to ask questions about the world around you and see whether or not what you know is adequate to explain what you see. Now, in front of you, you see Notre Dame. Now, if natural selection has, through adaptation, caused creatures to behave in ways that get their genes into the future, then Notre Dame is a bit of a paradox. So Notre Dame was set in motion by the Bishop of Paris in 1160, a guy named Maurice de Sully. Notre Dame took 100 years from the decision to build it until construction finished enough to use it as a church. It took 600 years for it to be complete. So in what way do we explain the decision of this individual, who, by the way, couldn't reproduce, to build this thing if what he was trying to do was get his genes into the future? Doesn't make sense. So we're missing something. That's a paradox, and we need an answer. Now, it could be that he was just confused, that he didn't really understand about getting into the future and was bad at it, and so he accidentally built this, marvel of the world. And you're laughing, but here's the thing. In my field, you will actually have people like Dawkins tell you that religion is a mind virus. It's a pathology. That's what they're saying. Pathology, really? So that marvelous cathedral is like, what, a cold sore? Seems really, really off. Way better to look at that and say, that is somehow a spectacular product of adaptive evolution that we don't have the tools to explain yet, and therefore we know we're looking for some tools, and we know kind of what they look like. They have to explain things like this, right? If that were the only cathedral, we could say maybe it's an aberration. But it's not the only cathedral. We have monuments all over the place. We have monuments that are every bit as grand as this, totally separately evolved in the New World, right? The Mayan temples, that were built, these things are incredible. Same weird problem hybridizing that with what we know about evolution. So, the tool we are looking for, I believe, is something called lineage. Heather referred to it. Now, unfortunately, when I say lineage, my field rolls its eyes. And there's a reason that it rolls its eyes. It does that because it hears group. I say lineage, it hears group. And Heather in my field is divided over the issue of what's called group selection. There are two kinds of evolutionary biologists. Heather and I are derived from the kin selectionists, and the kin selectionists believe that the argument over group selection was settled in the 60s, that group selection is a discredited idea, and there's no reason for us to be talking about it, certainly in, half a century later. The other group are the new group selectionists. These are people who say, not so fast, you settled that argument too hastily, and actually group selection does explain altruism between individuals who are not genetically related. Well, lineage is not group. In fact, lineage is a precisely definable fractal biological characteristic. And I'm going to tell you what a lineage is. A lineage is an individual and all of that individual's descendants. So if you don't have any kids, you're a lineage. If you have kids and grandkids, then you and your kids and grandkids are a lineage. Is this room a lineage? No, but it's not an idea you can throw out either. So what you would do is you would say, if we look at this room, what is the most recent common ancestor of all of the people here? That individual and all of that individual's descendants constitute a lineage, and this room more or less represents it. So, the thing about lineage is that, like I said, it's fractal. You are simultaneously a lineage. You are part of the lineage represented by this room. You are part of the entire human lineage. There was a most recent common ancestor for all people, and you are their descendant. You are also a descendant of the most recent common ancestor of all primates, of all mammals, of all creatures. So the point is, you've got all of these fractals. They are nested, or these lineages that are nested fractally inside of each other. And what selection must be doing is figuring out which of these levels of lineage to prioritize at any moment. Sometimes it's about you and your kids. Sometimes it's about your entire nation, which functions as a lineage. So, in any case, once we start thinking in terms of lineage and we stop thinking in terms of individual reproductive success, we can look at Notre Dame and we can begin to get an indication of how this might be evolutionarily sensible, right? Nobody said that the Bishop of Paris reproduced his genes by creating that building, but he belonged to many different lineages, which quite probably did. So, lineage is a key upgrade. And it also will allow us to see what I would call the illusion of self. I will return to this likely tomorrow. But we are programmed to be focused on ourselves because evolution occurred at a moment where we didn't have a lot of reach. So our focus on ourselves is really about the limit of our tools. It's not about the fact that selection cares about you particularly. In fact, if you were to focus on your own genes, the ones in your genome, and try to increase the number of them, 3 generations from now, you could spend every waking hour on that puzzle and you probably wouldn't move the needle, right? Because mostly what dictates how many of your genes are in the next generation has to do with a very large gene pool in which your genes are circulating and how successful it is. And that's a hard puzzle to solve. Okay, so next piece of counterintuitive stuff. If all of what I've said is true, then every evolved creature has the same purpose. That includes the spider, includes these foxes, these mushrooms, this strangler fig, and these bacteria in breast milk. All creatures have the same purpose. And that's a pretty frightening thing. It can't be much of a purpose if we all share it, right? I mean, you share the same purpose as smallpox. It's not going to be an honorable one. So, the upshot of that is that we, all of those different creatures you just saw, have different toolkits with which to accomplish that purpose. And humans, by far, have the most interesting toolkit. We are capable of reasoning our way through the puzzle, and we are also capable of rejecting the program or modifying it, which is something that we should do. So this all leaves us with a question which I will try to address tomorrow. If we are built by selection to lodge our lineage's genes in the future, what then is the role of human culture? That is a big question, and the answer is profoundly important, whether you're a scientist, you're in the humanities, or you're just a person trying to get along. All right. Thank you.
Dr. Weinstein, I was curious if you could explain what the big discovery from the 70s was and what that did to the field.
Yeah, it wasn't a big discovery. It was a synthesis, a work of synthesis. And science proceeds by two mechanisms that have to function together. One of them is reductionist, where we'll run an experiment that isolates something, and the other is synthesis, where we put things together that we've learned in all of these reductionist experiments and figure out what they imply. What happened in 1976 was Richard Dawkins he published The Selfish Gene. And the selfish gene is an excellent encapsulation of what it was at the time, the state-of-the-art understanding of the implication of genetics for adaptive evolution. And B, in chapter 11, he outlines the concept of mimetic evolution. Now, cultural evolution was understood a little bit. It was understood that it existed, but by codifying it in terms of memes, he opened the door to being able to understand human beings in rigorous evolutionary terms. Now, he made a giant error, which is not a big deal. We make errors, but he hasn't fixed it, which is in chapter 11, he says that the cultural landscape is a new primeval soup. In other words, he posits that the cultural landscape is its own place for new kinds of creatures to evolve. And as you'll see tomorrow, that is not the most parsimonious way to understand cultural evolution. And once you understand what the relationship between the already existing genetic landscape and the cultural landscape is, you'll see it has tremendous implications for what human beings have been doing for the last several million years.
Thank you. It seems like sophisticated intelligence, language acquisition, the rational faculty are features particular to the human being. And maybe they're the most adaptive part of human existence. And they seem to separate us from the rest of nature. Is it at all possible that the human soul is this most adaptive part of our nature?
I think you've nailed it in the first part. Language, although we certainly have antecedents of language, all of the things that you find in language have precursors in other creatures. I think Heather will end up talking a lot about those creatures tomorrow, would be my guess. But anyway, language isn't totally unique, but it is so radically augmented compared to the next nearest analog that it might as well be totally unique. And it opens the door, other creatures have cultural evolution too, but it opens the door to a kind of cultural evolution that is truly profound and special. The question about the human soul really is, what do you mean? I mean, I'm not discounting that there is something very special at the core of a person. I would argue it is wholly explainable by evolutionary processes, which does not, to me, make it less special. And I would argue that our discussion of souls and, some higher order to the universe is a very important set of metaphors that have, in fact, guided us, have allowed us to get into the future as we have, That doesn't mean that they continue to be adaptive. We can argue about that, but I would say you have a profoundly important set of metaphors, and soul would be one of them.
This appears to be in alignment with the last question, and I have it written down, so I swear I'll get it out. Thinking about this obvious tautology that the purpose of a creature is to launch its genes into the future as far as it can you talk for a moment on the relationship between humans and nature, and maybe the obvious need for a moral framework in order to be fit then?
Sure. I think if we understand what we are, and presumably everybody in the room would agree that life is an incredibly precious thing, and that we have been lucky to have it, especially not just to be alive, but to be alive as humans capable of regarding the world and understanding it and communing with others and all of the special things humans do. If you accept that that is a very rarefied good in some sense, I think we are morally obligated to deliver it to as many other humans as can possibly receive that gift. That does not mean packing as many people onto the planet at once as possible. That would be a terrible idea. It means stabilizing our behavior on planet Earth so that the place lasts, and therefore an indefinite number of human generations follow and are able to experience a world as good or better than the one we got, which means we can't go around driving important stuff extinct. We can't go around degrading the place. We can't liquidate its resources. We have to take sustainability into our set of objectives at the core level, take it very seriously, which is not easy in a competitive world. So I don't know if that answers your question, but I do think that this does have philosophical implications, and they aren't that hard to figure out.
So I have something to add to that. I think the more I learn about what else is out there, the less evidence for a disjunction between humans and everything else I see. It feels like a continuity, and it has to me for a very long time. And that may be the only real disagreement between a fundamentally religious perspective and an evolutionary one. That we are a fundamentally different sort of thing. That there's an addition, right? And even the prospect of there being something brand new with humans that is building on everything that came before isn't inherently an anti-evolutionary perspective. It's not the one that I have, but it's not anti-evolutionary. In fact, the man who may be the most important living evolutionary biologist, Bob Trivers, who was our undergraduate advisor, and he was the how do you say it? Officiant at our wedding, actually, is a believer. He is a man of faith himself. So there are many evolutionary biologists who do see reason to have faith in the world. But I guess the question about humans and nature feels like it creates a disjunction when I don't see one. We are in it, of it, through it. There is no discontinuity.
Yeah, I was thinking about the feeling that science and arts feel so separate in the academy today. I'm curious if you have thoughts about a reunion of those two things, what that might look like, what strategies one might consider to promote that, and also if there are any thinkers, writers that you find have beautifully represented a union of the two things that we now see kind of in disjunction.
I used to say when we were professors that it felt to me like the sciences being done as sciences, and the arts had in fact the most in common. And the humanities are sort of an encircling group, actually, and the social sciences were just on the outs, at least in modern times, because the sciences and the arts are fundamentally trying to understand what is true and why things are beautiful. And many scientists would not say that they are actually interested in beauty, but actually most of us are. So I don't have an answer with regard to particular thinkers who are bringing it together, although I think if you give me more time, I probably could come up with it.
I would just add, I talked a little bit about how off the rails the academy has gone, and really, it would be impossible to overstate it, right? Not a single biology department in the country stood up and said, there are really only two sexes and there's no two ways about it, and there's no excuse for that. It's an obvious fact. You may like it or not like it, but it's just simply true. But nonetheless, the point is that going off the rails that has happened in the universities is the result of a number of different processes, but some of them are just mundane economic processes. And one of them involves the universities are trying to get their scientists to bring in as much grant money as possible, and so they want them doing that full time. And the upshot of this is that the deal that the university makes with scientists is lousy. You effectively have to give up everything else. So even if under normal circumstances you would expect your best scientists to have some other side, some other way of relating to the universe, maybe artistic, they don't have time, right? So, the people who would make time for those things didn't make it. They're not in the professorships. And so anyway, those mundane economic factors in the university have made the place far worse.
I guess one more thing. This was one of the great features of Evergreen, which is now a failed college for sure. But the idea of being full-time in academic community with people for 10 weeks or 20 weeks or 30 weeks, a full academic year, as you indeed are here at Ralston, right? But that we could do that teaching undergrads at Evergreen meant that there was always room to do things that you wouldn't normally think of doing. And so, while in a standard 4-credit intro bio class, we just got to get right to it because they're going to have to learn the Krebs cycle. Do they though? Not sure they do, right? And we would always start with the philosophy of science because that's where you have to start. You have to start with how are we making claims of truth, or else there's no way to know what you actually know. And then time in the field, breaking bread with one another and throwing the frisbee and sitting around a campfire and just, and being together so that by the time week 3 starts and you've done a bunch of epistemology and cooking and camping together, you could start looking at each other going, okay, what do you think is true? Yeah, I don't think so, here's why. And now you have respect for one another, but there's also room in the curriculum. And so, the disagreement isn't taken as an assault on my person. It's actually like, oh, we're actually here in community having a conversation in which we disagree, and that's fine. But there's also room for art and literature and more philosophy and many other, and music and many other things as well, when you have the expectation that you're here full time and that this is what we're all doing together. So I think that's a model that really works.
I want to just give you one paradox. Science is an art, right? There are parts of it that we can describe how you do it, and then there are parts of it, the most important parts, we can't, right? You tell a student, formulate a hypothesis for those observations. Well, professor, how do I formulate a hypothesis? I don't know. We just all do it. We ponder. We, look out the window. We take a walk. How do you formulate a hypothesis? You have to develop the skill within yourself, and it's not a teachable thing.
So I am in the midst of challenging some medical paradigm, but I'm also at the bottom of the medical establishment with my degrees, if you will. That said, you spoke earlier regarding moving science forward, especially when it is antagonistic to our previously held beliefs. What is to both of yours opinions, what is the most effective way to challenge what we have held almost dogmatically without coming across as militant and potentially stepping on the toes of those who may actually give us the room to be able to spread our ideas?
We make a deal in science, those of us who are actually committed to it, which is that we are probably in the end net better off if we know. And then having done that, there are no rules on what questions you get to ask. And there are some very awkward questions, to be sure. Personally, I believe that if you took all the awkward questions and all of the places where you will be relieved at the answers, in the end, we come out way ahead. The bargain is worth it. But there are no guarantees on that front. So really the point is you need a community of scientists that is agreed enough on that. There's nothing you're not allowed to say, doesn't make it true, the arbiter of whether you were right is predictive power over the long term. You may not live to see your idea vindicated, but if 300 years after you're gone, it turns out that your idea predicted things that other ideas didn't, you were right. So it is that agreement that motivates scientists who are actually, who live up to that term, and the answer is we just have to go back to it.
I guess I would just add that with regard to worrying about stepping on the toes of the people who might be your allies, what we've seen, not so much at Evergreen, but during COVID and since, is almost the only thing you have to do is indicate a tiny bit of openness to the conversation that is not the dominant one. And everyone from the dry cleaner to not the doctors, everyone else almost will open up and say, oh yeah, I too don't believe. I too don't believe that they're safe and effective, that men can become women, that, whatever it is, that, we live in an entirely racist society and that is the only defining thing by which we should be understanding our world. Whatever ideology it is that we are currently suffering under, I almost think it's a majority of people who are actually silently understanding what is true and just being silent about it, such that your allies are probably, if your allies are feeling that their toes are stepped on, maybe they're not allies. Because I think actually people are relieved to find dissent at the moment.
One of the dynamics that, Heather, you brought up in your talk was showing how things that seem unlike are like, and I believe it's Aristotle who, well, before I get to Aristotle, let me say, Bret, one of the things that you spoke about was how fundamental a grasp of biology is to understand other things. And certainly Aristotle would be the first to agree with you, having made studies of all the elements of what you might call the world or the cosmos, from physics and nature of various forms to the stars, to the soul, to ethics, metaphysics, etc. So to relate these comments, you've given us these beautiful examples of how the things that don't look the same are actually more the same than those that do. And it's Aristotle who says that metaphor is showing how unlike things are like. And I think your talks have already, for me, been very, very rich in relation to the questions that we're often pursuing at Ralston College, which might seem very unlike to the topics of your talks. But in fact, I'm seeing all kinds of patterns, including the ways in which the unlike are like, as revelatory, insofar as the biological, the natural, is you might say, the substructure for all of the things that we're thinking about. The question I want to pose here, Heather, you said that the laws of physics are not invented, they're not evolved, but they're discovered by us. And Bret, you hinted that the cathedral perhaps might have an account at some level, and we'll get to this tomorrow, human culture, as a matter of our evolutionary structures and so on. The question I have for both of you is, do you think that everything can be accounted for fundamentally from the standpoint of the evolutionary, or, for example, the laws of physics? Did they themselves, in some sense, evolve? And if not, do you think that there are fundamental realities or principles like the laws of physics that are themselves, you might say, in the driver's seat at some level, or at least setting the scope of what can evolve?
The latter.
Uh-huh.
Yeah. No, they're not evolved, and therefore we live in a universe by this model in which evolution happens according to the laws which drive it, which we cannot change. That said, where you started with metaphor, I would say that scientists traffic in metaphor much more than, and here I want to use the they rather than the we, than they want to admit. We all use more metaphor than we know. All of our language is more metaphorical than we know. Even the idea that it's hot today and therefore the temperature was high, right? This is metaphor. There's nothing high inherently about a hot temperature. So there's metaphor everywhere, and I think the language, the framing that we have in all of the sciences is informed by the metaphors we have used, and if we can't see that we are basing them on metaphors, then that's going to bias what we can do.
I'll try to do this quickly. I've coined a term, metaphorical truth. And metaphorical truth, these are things that you do better if you act as if they are true than if you act according to the fact that they are false. So don't take this as a provocation, but let's just say if there's no actual being in the sky looking down on us, it doesn't mean you're not way better off thinking as if there is, and there are lots of reasons that it might enhance you. So the evolutionists, the strict evolutionists, tend to look askance at the metaphor over in human space, especially what appears to be obvious metaphor like, a creator God. But what they don't understand or acknowledge is that inside of science, we actually have the very same thing. So we have these patches of knowledge. There are things that we understand very well. The hymenopterans that have the weird genetic system, that we get. The termites, we don't really get. So you've got this, imagine a big picture that is all of biological reality, and we've got parts of it that are painted and parts of it that are barely sketched in. Well, what do we put in those places? We put metaphors. We have things we say that allow us to skip from this zone that we understand to that zone that we understand. And the longer the scientific process goes on, when it works, the more gets filled in. But the point is, we have to at least be honest that metaphor is not the problem, because we scientists, no matter how rigorous we're trying to be, are using it all the time anyway, right? It is so early in the study of biology. We know such a small fraction of what there is to be known biologically that it's mostly metaphor at this point, which doesn't mean it's wrong. It just means it's very approximate.
In light of that last question, I was curious, I wanted to pose a paradox to you two. Do you think there's a way to reconcile the creation story in Genesis with evolution?
Yes, but I don't think you're going to like the answer, but I'll give it to you anyway. If you think about a religious belief structure, right, the entire package of all the things you believe if you belong to this religion, not all of it is doing the heavy lifting. I would say the heavy lifting is in the beliefs that modify your behavior, right? But there's also, just as not all of the tree is producing, sugar out of carbon dioxide and sunlight, most of the tree is holding the leaves up where they're not being overshadowed by something else or collecting nutrients from the ground. So the point is, there's a lot of overhead to doing photosynthesis. There's a lot of overhead to giving people a package of recommendations for how to live that allows it to work. And so my guess is that actually it's one of the great vulnerabilities of that tradition is that when those stories were written, there was nobody in a position to say that can't possibly be right. And so they were good enough. And now that we're in a position to say, actually, that story can't possibly be right, it basically upends the important part of it, which is the how should we behave towards each other part, right? It's a vulnerability because nobody knew it was going to get falsified, and unfortunately, that's what happened.
Unless, of course, there are mythological structures that have continued predictive power in their account at non-literal levels.
And this is the damned if you do, damned if you don't part of it, which is if you start to recognize that a religious tradition is adaptive, which is where we're headed tomorrow, as you'll see, once you realize that, you might start thinking, well, maybe we can edit down to the parts that are actually useful and not overhead. You can't, because you have no idea how it works. We have no mechanism. There's no, if it were a computer code, there'd be comments in the code that says this algorithm does this function call does that. And you could go back and you could say, oh, this one's no longer relevant. Oh, that one's still important. There's nothing there. So the point is, if you throw it out, you lose a bunch of stuff that was doing something you didn't understand. And if you take it as it was, then it's a bad match for a modern world that doesn't look anything like the world in which it was written. So that's a serious predicament, and we're going to have to figure out what to do about it.
I just want to make a quick comment about that because it's so clear that we're in a deconstructive moment in our culture. And I'd like to give the metaphor that when we moved to Prince Edward Island, as when I was a boy, there was a wall that my father wanted to smash down in order to open up part of the house. And it was Mother's Day, I think it was 1984, and he's a big guy, 6'5", not even 30 years old, and he started just smashing at this wall, and everything was going everywhere, and there was one particular post that he started smashing on. As it started to come away from the ceiling, the whole roof began to sag because, of course, he hit upon a load-bearing pillar in the house. And, of course, he stopped, and they got it sorted out with a contractor the next week. He's not a rash man, actually. He was just, trying to open up the house a bit. And he stopped at the right moment. But the point I wanted to make is that, we have not stopped at the right moment because insofar as tradition or culture is, let's just posit, an evolution, an evolved structure, there's all kinds of things in it that we maybe not understand the dismissal of which may hurt us. Michael, and then Joshua, and then we'll get maybe one or two others in quickly.
While the microphone is coming to Michael, I'll say you remind me of it's one of the foci in Hunter-Gatherer's Guide to the 21st Century, which is Chesterton's fence, right? Chesterton being an early 20th century philosopher, I think, who said, look, when you come upon a fence that is in your way, your response should not be to tear it down. You have to figure out first what it is there for in the first place, else you should not get rid of it. And we refer in the book to things like Chesterton's breast milk and Chesterton's religion. And this is exactly what you're talking about. Like, you caution before you get rid of things that are long-standing and have been useful.
Right. You don't know what the load-bearing pillars are, don't knock them down. Yes, Michael.
I could not have asked for a better segue, and I was curious, what would you name as some of the crocodiles of human culture or behavior?
Oh.
Golden rule, which actually does not start with Jesus, but the golden rule has antecedents in at least 5 different places on Earth, and my guess is if we had better documentation, we'd find it in a bunch of others. But anyway, it tends to get deployed towards an in-group. And there's talk about this more tomorrow, but tends to expand out over time. But anyway, that's a good one. That's a long-standing, unlikely to be wrong go-to strategy.
So I was going to go to less, maybe not as interesting answers, but basically what things haven't reversed. Things like, once jaws evolved, they never reversed. Crocodiles are mostly the same as they've been. Once backbones evolved, they never reversed. Whereas legs, super useful, and then a bunch of critters lost them, and it seems like they can get along just fine without them. It's not just snakes, right? So what in human culture, once it was picked up, didn't get reversed is a different question than is definitely universal. I would say, for instance, agriculture. I don't think anyone has given up agriculture, even though not all human cultures have agriculture. Written language, I think.
Written language gets lost.
But then picked up again.
Yeah.
We were just talking,
Joseph.
Yes. We were just talking to Dr. Conlon yesterday about this. It's amazing, but it's like this short oscillation pulse, right? That it comes back for people, or people come back for it, I guess. And
agriculture, and as long as you're going there, fire,
cooking food, which is different from fire,
yep.
but once you've cooked food, which sounds like this trivial thing, but Richard Wrangham, who's a primatologist who does really great work, has a hypothesis, and it seems compelling that one of the things that allowed humans, including our brains, to expand so fast and to become the dominant species that we are, was once we started cooking meat, as opposed to eating raw meat, the amount of time we had to spend chewing every day dropped by many hours, and we suddenly picked up all of this time in which to do things like create art. So just the fact of being able to pull more calories out of a meat by cooking it, and of course you can cook other things too that you couldn't eat raw, but that's another. It's a fun question.
It's very interesting on this topic, and maybe we'll be able to get into this more tomorrow and on other occasions we have with you. One can imagine. One can well see that there are no surviving cultures that don't have, agriculture or fire, for example. But you could imagine that there could be cultures that survive without song or language.
I think music is universal.
Yep.
Universal?
Yeah, and actually
agree.
there's a great little book that's hard to find called Human Universals, written by an anthropologist in the 70s, I believe. I finally got myself a copy. And it's, there's things like, once they evolve, they don't disappear. The concept of zero. Not everyone has it, but once it shows up, it doesn't disappear. Once you get to, so like black and white and red are the first colors that always show up. And once you get them, you don't lose them. And then the other colors show up in the same order all the time, almost. It's black, white, red, and then it's like blue or green, I think, and yellow. And there's not that many fundamental colors, and they always show up in the same order across cultures where they do, which is fascinating.
Thank you. What's the difference between lineage and race?
Great question. Terrible question, but great question. Race is a racist bastardization of lineage. Okay, so if you imagine that the evolutionary game is to get your genes into the future by any means possible, then one of the ways you will do that is by lying about lineage, right? So the point is, there is a relationship, and I know people don't like hearing this. I'm saying it because it's true, in my opinion, and also because I believe it provides the solution. Once you understand the problem, human lineages displace each other because it is rational to do so. Monstrous, but rational. Okay, that means it is comprehensible in evolutionary terms. It is not something that we are condemned to do. There are alternatives, but you have to understand that evolution is going to point you in that direction, and you have to build the correct structure that we do not get lured into that pattern. But once you do, you will end up, using concepts like the one-drop rule of race. That doesn't sound very biological, right? That sounds like an excuse, and it is. So the point is, race is a bastardization of lineage that has been adaptive for cultures who were in the process of displacing each other or thieving from each other or any one of a number of things.
Thank you so much. I wanted to ask about hypernovelty and how that plays into human behavior today, especially coupled with a desire and ability to control for uncertainty with Amazon, with Grubhub, with everything like that. There's a control for uncertainty, but there is also hypernovelty. So how do those interact with each other?
I would argue, there is certainly an analogy between the way genes evolve and the way culture evolves. It's not the way Dawkins says, where culture is its own new evolutionary thing. But nonetheless, the process of selection amongst cultural traits is similar. But what is radically different is the rate of generation of new cultural traits and the rate of extinction of those traits. So you are living in an era in which almost nothing that you're interacting with has stood the test of time. So that means that unlike with the structures on a creature where you can say, that structure, I don't know what it does, but it's got to be adaptive or it wouldn't be on that creature. You cannot look at modern human culture and make that same assumption, because most of these things will probably go extinct because those who engage in them are not doing themselves a service and are probably doing themselves a harm. So you're in a zone of noise in which you have very little to go on with respect to what will actually last. And that means we can look backwards. We can say, what the Maya were doing, the building of these large onion-like growing temples, that has to have been adaptive. We don't know why, but it has to have been adaptive because the investment is so high. But you can't look at, for example, video games and say, the investment of humans in video games is high, it must be adaptive, because the answer is it may be that the people who don't play them outcompete the people who do, and that we'll find that out in 50 years.
Thanks for your talk. I was wondering if you could provide a definition for species.
Good
Nice
one.
softball one for you at the end.
Yeah. The answer is there is no definition of species. That our desire as humans to categorize the world in tractable ways leads us to believe that there is something called species because there is something called speciation. In other words, the process that takes one lineage and divides it irrevocably is real. But the problem is there's a gray area that defies any definition. So, what do we do with ligers? Lions and tigers do not live in the same place, so they don't produce offspring. But if you put them in a zoo environment, they can breed. Is it a species? Is it not? We have innumerable examples like that. So I would say species is a bad concept. Speciation is a good concept. Genetic is a good concept. Gene is a bad concept. We have a lot of these things where we just sort of over-extrapolated because it seemed logical to do it, but the world wasn't built for us to understand it, and some of our categories just aren't going to work.
Let me just add something to that. At one point, along with my advisor, we generated a list of species concepts that were being used actively in the literature, and it's dozens long. Right? A species concept being, how do you put into action the idea of species such that you can then say, okay, I've got a new species here. And the one that we've all got in our heads, if you've got one at all, is the so-called biological species concept, which is a weird name for it because isn't it all biology? Yes. But the biological species concept introduced by Ernst Mayr is, can it reproduce? Right? Can those two things reproduce and make viable offspring? If so, they're the same species. If not, they can't. End of story. Well, what do you do with fossils? You can't put fossils together and expect them to reproduce, so okay, we're going to need the paleontological species concept. What about when you're looking at organisms that don't have the kind that are asexual? That there's a number of lizard lineages actually that are asexual, and it's just all the same. So a clone is a species, except there's another clone over here, and sometimes they go out of asexuality in order, we think, to introduce new genetic material into them. And then so is that species and that species the same for the moment, and then it's different species? So you begin to see why operationalizing the concept is impossible. That's why Bret says, I don't say the same thing you do. I don't say there's no species or species itself is a bad concept, but speciation is utterly real. It is the thing I was talking about with regard to macroevolutionary change. The deep history and how and what the relationships that are left behind are. But is it possible for us to find a single stable definition of species? No, it's not, because that's not how biology works.
And I would also point out you will get a whole other layer of trouble tomorrow when we talk about humans in this regard, because as bad as it is with animals, we've got an even weirder situation with people.
Well, if that isn't, I think, likely to produce a good crowd in tomorrow as our immediate future, I don't know what is. Please join me in thanking Bret and Heather for a wonderful evening.